Hello everybody. In this session I'm going to focus on finishing up the ECS integration. But first of all, I want to explain a little bit how ECS works from my point of view, from what I've seen so far from the code. And I think the reason I want to explain this is because I want to make a short series of like a 5-minute explaining ECS, but also explaining the architecture and the way you deal with the state and how this differs from OOP and OOP standard approach. So first of all, what I've noticed is that in ECS you need the concept of world. And I think this concept of world is also, it's named differently in other frameworks. Let me see. So in ECS, I have the concept of world, which is controlling, which is a class controlling all entities and systems and queries. How is this class generally named in other ECS libraries? I presume it's also scene, so you can have world or scene. Engine, scene, universe, registry, manager, ECS context, space. Yeah, so at least ChatGPT says that space can be used like this. The reason why you need this class world is because whenever you are creating an entity or a system or maybe a query, the system, the world needs to know about this and have some sort of list where it stores all of these classes, instances. So let's start with entity. So you can create an entity, and that means that an entity is just an ID. But inside an entity there are components that are being added. Components are mostly decoupled. They exist in a free state, so they are, first of all, they are registered in a registry, so you need the instances of that particular component just for this is actually an important step in every ECS out there, because registering a new component means that you assign it a bit mask or a unique identifier, which is carried on in every instance. So one component is mainly composed from a bit mask and some properties, which usually are called data or state, because the state is kept on the components. So components are only a shell for data, and entity is only a shell for entity ID. So it's like an ID, unique ID in the database, and all the components are tied to the entity. I'm gonna come back to this bit mask of each component, but generally speaking, if you have two components attached to an entity, by looking at the bit mask you can instantly tell that. So that's why there's a need of component registry. The next concept, which is kind of outside of the terminology ECS is a query. A query is represented by a filter of components. It can be a filter that it has positive or negative, but it's based on solely on components. It can say, give me all the entities with component A, B, or X, or give me all entities with component A, B, or and they don't have the X component. So generally, a result of a query is a list of entities that satisfy this filter. Now, a query is finally used in a system. Of course, it can be used in multiple systems, but a system operates on a query and updates every entity. So the update goes back to each entity and perform various operations. What does that mean is, let's see in terms of code. So first of all, we define a component. It's a plain data shell. So this is just as you can see, position only has X and Y, keyboard only has up, down, left, right. No methods, no logic in here. Then you define an entity and you attach components to it. Can I enlarge this? No. So you just use add component and you can add like this, properties. So you can add a body with properties, you can add position, direction, keyboard, sprite, and some of the components can be tags. Tag component, that means that a component doesn't have any properties, so it's just there to signify that, hey, maybe this entity is in a certain state, is renderable, is idle, and something else. Then a system, as we discussed, the dependency of a system is usually a query, and a query is a filter of components that operates on entities. And finally, you have the game loop. So after you have all your systems instantiated, which, by the way, the order matters because you want the input to act first on the first place, and then you want the rest of the systems, and then finally you do the rendering. And you can see it here from the loop. So you have the loop of your engine, and each of the system has an update method, and the update method operates on this, the result of the query, which is each entity. And you may ask, okay, what if in this system sometimes we create new entities like flying bullets or new enemy? Then an entity usually has a way of registering events callback on it. So every time you do an add component or a remove component, you also notify whoever it is interested in this, so that you can update all your queries based on the filter. So let's say that here an entity adds healing is healing, right? So you add it, and then you check each query that you have registered if it satisfies the filter, if the component is satisfied by the filter. So for example, if one query requires this the component that this entity has, then you announce the candidacy to that particular query, or you announce the removal of that particular query. And then here it's just adding a new entity. Bam, you have a new entity. Then at the next loop that you will have here, you will probably be processed by one of the systems like health systems or is healing system or healing system or something like that. And the state in ECS, after some iteration and long deliberation and checking up this data-oriented paradigm, which is ECS, sorry. It appears that the state is actually kept on the components, on the entity's components. So you only operate on these properties. You update them continuously. So when you want to save the game, for example, you will only look at the properties and serialize all the properties. So basically you will end up with having an ID which has bitmask multiple component rows, records should I say, which have a bitmask and some properties. And I think for this I should represent this here in a table. Let me see. How can I do that? Table. Oh, I have a table. Oh, okay. So, wait, what? Entity. So you have entity ID, component bitmask, which is like its ID, and you have component data. Let's increase the font on this one. Okay. Can I change the color of this? I don't know. What ifs? And okay, background color white. So you would have something like entity ID player, component bitmask, let's say 001, component data x 103, So this is like a position. And then again, you have the player. 1, 0. And then you have width 16. 16. Well, I don't get why this text is so small, but it's probably a bug because I have no way of making it larger. Okay. What other components we have here? Key binding up. W down S left A right. What's happening? Hi, Mike. Yeah. Are you by any chance familiar with the paradigm of entity component system? Because I find it fascinating. B, okay. Pretty fascinating. This is health, stuff like this. And then you can have say Dino and X 200. Okay. And so on. Now, from what I've gathered from the articles on the internet, there are many ways of storing this data. And let me go here. There was this Where's the article? I think I started somewhere. Start. Where were the repos? Stars. So someone by the name of Sanders Mertens has documented an entire FAQ for ECS. And on the storage design, he wrote something very interesting. How to store data. And there are two types of storing the data. So there's one like this, which I believe it's sparse. A sparse way to, let's see, archetypes. An archetype ECS store entities in tables where components are columns and entities are rows. Archetype implementation are fast to query and iterate. So these are archetypes. What is happening? Okay. Archetypes. So could I name this? And there are also sparse sets based on ECS. Actually, this is not archetype. So this is the sparse methodology of, because you have many entities and no, you have one entity and many components, and you only have like 3 columns. And there are archetypes in which components are the columns and entities are the rows. And this model is like this. Entity, okay, and you have component position, body, keyboard, health, etc. So you have position, So you can already see where this is going. And here you don't necessarily use you don't need the bit mask or unique component identifier because it's already determined by the position of the column. So basically the column will be your component ID. Okay. And I need to explain how OP is fundamentally different from ECS paradigm. So you have class player extends actor, implements identity. Constructor properties, and then init so we have an init. So this is like a lazy init where you have state, new state manager, this state add state the state, state okay, and then And then what we got here? The game loop. How does the game loop looks? This loop. Running a game loop is like this. Okay. I think I'm fine with everything that I have here. I just need to implement this, make it work, and maybe find another way to explain the bit mask here. The fact that components are unique. Let me figure out an explanation here. And yeah. I'll be coding in the next session.